Faith Musili, and together with the other organizer, Chris, who will join in a short while, will be the Zoom host for this session. On behalf of the organizers of Our Ladies Nairobi, we welcome you all to this session. To the participants, for any questions you have for Dr. Tor, please go to www.slido.com and enter the code hashtags at @RDayNairobi _06. I'm going to post that in the chat and type in your question, and then we're going to ask Dr. Tor that question. So let's just use the Zoom chat for only the introductions, if any, and the technical hiccups. If you can't see the screen or you can't hear him, that is the only time you should be using the chat, please, if possible. So all the questions, let's do that via Slido. Finally, please know that this is a safe place, free of harassments to everyone. If anyone behaves in any inappropriate manner, we are going to remove you from this session. In this workshop, we will explore how modules can help us better manage Shiny apps when they become a large, my net just went, so let me switch. Just a minute, I switch. Okay. Right, sorry, my internet, my electricity disappeared. I hope everyone can still see me. So I'm in the darkness now, sorry for that. So I was saying that in this workshop, we'll explore how modules can help us better manage Shiny apps when they become a bit large or complex. We are going to develop a single dashboard with maps, graphics, and some simple statistical models for analysis, if time allows. And we will be using data from the R Kenya Census package that was developed by Shell Karaoke. And you are going to be shown how you are going to install that in case we have not. The workshop builds on a number of R libraries, such as Leaflet, SF, Data Table, Plotly, ggplot, and of course, Shiny. We will use Shiny React, Shiny Router, and Shiny Fluent, which are all developed by the amazing team at Epsilon. About our speaker, Dr. Tor, is a principal scientist and the head of the Spatial Data Science and Applied Learning Lab at CIFOR-ICRAF. He has a background in soil science, hydrology, landscape ecology, statistical modeling, computer programming, and remote sensing. He currently leads research initiatives to establish global data-driven networks of sites and comparative assessments of ecosystem health, linking Earth observation data and models to biophysical and socio-economic variables, and to understand the drivers of deforestation, land use change, and land degradation, and also land restoration potential. He has also been leading several projects and initiatives that explore spatial data science and user-centered design principles in the core design of interactive tools and platforms for evidence-based decision-making. I'm really glad to introduce Dr. Tor, and I really hope that you're going to learn from this session. So over to you, Tor.
Thanks, Faith. Hi, everyone. So I'm going to start sharing my screen, and then we're just give you a quick introduction, and then we'll move into the fun part of the session and the actual kind of coding and so on. So just a little bit of a background on myself. Faith already mentioned some of this, but I just want to mention that I'm not actually a coder or a web developer by training, but I do enjoy coding, data visualization, and app design. So my background is in science, and Faith already introduced me there. But I've been using R extensively since about 2001. I initially started my sort of journey in coding in MATLAB and other environments, but for the last almost about 20 years now, it makes me feel really old. I've been using R extensively, but I also enjoy working in Python and do a little bit of Java and JavaScript as well. So coding is really something that I'm quite passionate about, and it's very nice to be able to introduce Shiny modules today. And we're going to do this very much hands-on, and you've seen, I hope, the link if you in the chat that Faith has pasted there. to the GitHub repository. So if there are things you can't, like if you're not able to follow, because I will be doing a little bit of live coding, but also a bit of pasting into the script, so to save time. So just feel free to open that Git page or clone it or do whatever you know to access the slides, the scripts there. One of the reasons we use Shiny modules is that often we want to break our Shiny apps into smaller and more manageable pieces. And this might be for different reasons, obviously. So maybe your app is becoming complex, or it has many moving parts. Maybe it's difficult to maintain. We all know from early Shiny days or any other kind of web development, but in early Shiny days when we were basically working with either one app script or maybe a server and a UI separate, they can become quite difficult to maintain over time as they expand and you get thousands and thousands of lines of code. Also, modules are really handy if you're working as part of a team. So if you have different components of an app that different team members are working on, this is a really nice use case also for modules. And then, of course, you might have cases where there are elements of your app that you would like to update more frequently, while others may be more static. So that's also another good reason to use modules. And lastly, but not least, the reason I started moving into using modules was basically that I wanted to be able to reuse elements of a Shiny app across different, apps. So basically, we have, for example, some of the research we do around soil and land health. We do a lot of spatial work and a lot of mapping, machine learning, and we then have modules that we develop that are kind of specialized in that space that we can basically then plug into other apps. So that was one of the reasons I moved into it, and there are many more, and feel free to put some in the chat if you have other sort of scenarios, use cases, reasons for using modules. One of the important things to remember, and we'll be looking at this extensively, but a Shiny module has its own UI and server logic. So basically, when we develop an app using modules, we have a part of the app that is controlling everything, which we will start with in a minute. And then we have the modules as separate scripts with their own UI and server logic. They're actually, you often hear, and I know this is also called an advanced sort of Shiny session here, the workshop, but Shiny modules are actually not that advanced, but they can be used in really smart ways to develop incredibly rich and advanced Shiny apps. So I hope we can unpack it today and just kind of show you that it's absolutely approachable, and they will definitely make your life a lot easier. So with that, I'm going to just switch into some script here, and I hope you can all read this. And so I know a lot of you will be working in RStudio. I personally work mostly in VS Code. So, but this is kind of what the empty environment, almost empty folder looks like. What you see on GitHub, it's already populated with the modules and everything else. But we're going to start here, and the beginning of an app is with using modules is the app.r script here. But I'm going to keep this very simple, no complex folder structures or anything like that. So we'll try to keep it as simple as possible. But if you notice here on the right in my shared screen, I have the app.r script here in the folder. And then I have a www World Wide Web folder here where I have a CSS script with the styles. And we're not going to go into CSS a lot today, although Faith had asked me in the beginning if we could cover some CSS. I mean, we'll look at it quickly now, and then we'll move into the app, the main app script. So if you've downloaded this from GitHub, you'll have all of this, so you don't need to code all of this, and we're not going to go through the CSS, but basically this is where the different sort of grid containers, the style elements of the app are in terms of the header, for example, the side navigation, and the main area of the app. So what we're going to be developing today is basically a dashboard, a very simple dashboard, which has a header, and it has a logo. It has side navigation on the left, and it has a main part where the main content goes, and then it has a footer. And then there are other elements like the title, etc. here. And some of you, I'm sure, are really wizards at CSS, so you'll find this very intuitive, and of course CSS gives us a lot of flexibility here, like in terms of styling our app and customizing to our heart's content. The only thing I've added here beyond what comes standard if you use Shiny Fluent, the library, is I've added a style on this card here, which we'll be using when we get to the modules. And so, yeah, that's it. That's the CSS file, and that lives inside that www folder at the root of our, so over here at the root of our project folder. So let's start with app.r, and feel free, I'll try to look at the chat if I can, but and if there are questions, but I've told Faith to interrupt me if there are any pressing questions as we go. So don't worry if you interrupt, that's fine, and then we'll pick it from there. So when we start off here, I've just now sort of added some of the initial parts, and of course we need our libraries. So here we have Shiny Fluent, which is what we're going to be using for our interface. Shiny Fluent is developed by our friends at Epsilon, which is a company based in Poland, and they do a lot of amazing work with Shiny and enterprise scale kind of Shiny solutions and applications. And then it had one of the dependencies of Shiny Fluent is Shiny React. So these are basically wrappers on the Microsoft Fluent UI. It's kind of framework, which uses React as well. So these are kind of our wrappers around these frameworks. Then we're going to introduce something called Shiny Router, which is something I personally actually discovered not that long ago. But it's a really, really handy approach, especially in terms of, for those of you who have developed some Shiny apps, you'll know that in conventional Shiny apps, if someone reloads the app, it goes back to the starting page. So it sort of restarts the entire thing. But with the router functionality, people can refresh the page they're on, and it will basically come back to where they were, which is really quite a handy feature. It also makes the page navigation much more efficient in some ways, and then it can allow us to share URLs to pieces of an app rather than, for example, having to go to the landing page and then navigate to that section of the app. So that's something that we often find, with a lot of the people that use the apps that we develop. Basically, that's functionality that people tend to really like. Then we're going to use data table. These can all be installed from CRAN. If you look at the Git repository, there's also some instructions for Shiny Router, React, and Fluent in terms of installation. So you can, if you don't have them already, you just copy paste what's there, and that should work. Then so data table, we're going to use just to do a little bit of manipulation of the data that we're feeding onto the dashboard. I decided to use data table today as an alternative approach, just to introduce something that maybe a lot of people don't use. I know that the tidyverse and dplyr and so on is something that most people are more familiar with. And then we're going to use Plotly for a bit of graphics, leaflets for some maps, and there's a couple of additional leaflet sort of plugins here, which I don't think we necessarily need today, but they're there anyway. And then the SF library, which we will be using to do a little bit of reprojection and a little bit of work on the county map for Kenya, which is in the library that Michelle Kariuki developed. And that's finally the last one here. Our Kenya census is the library we'll be using for our data and also for the map. So essentially, as you can see here on the right, there's no data folder in this app or anything like that. So everything we'll be using, this is to keep it simple as well in terms of this session, everything we'll be using is in that our Kenya census library. Now, the other things, if we look down here at the rest of the app here, it looks quite familiar to those of you who have developed Shiny apps before. We have here in the app.r script, we have a app UI section here, and then we have the server logic here below. So that all of this should seem quite familiar to most of you. But I'm going to go ahead and put some things in here that are basically kind of specific to the Shiny Fluent part of what we're going to be doing, and the Shiny router. So first, what I want to do is I want to create some routes for my pages in the app, and I'm going to just paste that in here. So I'm just putting, before we're going to go into the app UI and server later, but first we're going to set some functions up and some things up to get ready. So basically what we're going to do is we're going to develop a dashboard, as I mentioned, and we're going to have two quite simple modules. We're going to have a home module and we're going to have a map module. So for that we're going to use Shiny router and basically define the key for the two modules, and then the UI element of the two modules. So you can see here a make router function, and then the route to home and to map, and then the Shiny, the div, which contains the UI from the respective modules. So we haven't made the modules yet, so this is just setting it up for now, and then in a minute we'll move into making the actual modules and the scripts for the modules. Another thing we will need or want is basically different sections in our page. So I'm going to put in a section here for the header. So what I've done here is essentially do a tag list, so with an image and a title. So let's change the title to our unofficial. Unofficial, my spelling is not so good today. And then we have here then basically the image, which is the flag of Kenya. It's just a URL there that you can paste from the code repository. It has class logo, so that one is going to go in the top left corner of our app. And then we have a div or a section where we have some text, and that function text comes from Shiny Fluent. And then which has a variant, extra large, which means it's extra large text, and then the text we want, and the class is the title, right? So the class is what we use in terms of the styling, and so that our CSS part knows what to do with the different parts of the app. So that's the header. So we have routing, we have the header, and then we're going to do the navigation, and then it becomes a little bit more involved when we look at the navigation part. So I've pasted this in, but we're going to walk through it now, so slowly. So basically, we are creating an object as you would in R and generally called navigation. We're using this function nav, which is from the Shiny Fluent. If you do help nav, you'll find the description of it. And then we're defining the groups that are going into our navigation bar. This is the bar that will be sitting on the left of our screen in the final app. And then these list functions are basically, because we're passing this into Shiny React in the backend. We're not going to go into that today, but essentially we're going to have two really simple sections in our navigation. So one is the home page here. So we have a list and links equals list, and then the name of the page. So that's the name that we'll see in the navigation bar on the left. Then we have the URL. So that's the internal URL that I talked about earlier. That allows us to kind of share individual parts of an app with users rather than jumping all the way into the landing. And then we have a key for this, which is just an identifier, and then an icon, which is from Microsoft, basically their icon sets that come with Fluent UI. And I'll show you in a second a little bit of some of the document. There's an amazingly rich documentation on Fluent UI from Microsoft as well. And it's a really pretty interface just out of the box. So that's another reason why this is sort of a nice way to start. You don't have to do a whole lot of tweaking to begin with to get quite a good looking dashboard. Then our next part of navigation here is the map part, the mapping, and we have the URL, again, internal, the key and the icon map again. So same procedure as above, 2 sections. And then the initial, what we are setting down here, once we escape the list of the groups here with this parentheses, we set our initial selected key, which is home. So that's when we open the app, we want it to display home. And then here we can display or add various types of styling to this as well. So there's possible to kind of tweak this with borders and background and other things. But you can also, a lot of this can also be achieved in the CSS script in the www folder there as well. But this is just styling it using, again, the Fluent UI library that's this is wrapped around. So that's the navigation part. So we have a router, we have a header, we have navigation, right? Now we're going to just add the footer, which is a bit simpler and absolutely not something we necessarily need, but it can be quite handy. So I basically here created a footer, which is horizontal, goes across the bottom, obviously. I can set the alignment here, and you will see what that means when we finally run the app. But basically, what we're doing here is we're telling it we want it to spread the elements of the footer out across the screen at the bottom within the footer. Then we have some text that we're adding to it. Variant medium. Medium just means that it's medium size. We could do variant large. We could do extra large. We could do small to tweak that. And then there's some text here which will go in the footer. And then down here, another one where we will have some text that goes in the footer to the right of this one. So whatever comes first there goes to the left, next part goes to the right, and then it gets spread across the width of the viewport. So this is the horizontal align part. Okay, so now we have a header, navigation, and the footer. But now what we need to do before we move into actually putting it together, we need to bring these elements together. And for that, we need a function, right? So I've called it, this is pretty much taken out of the box from the documentation that you'll find on Shiny Fluent. But we basically are defining a function called layout here. And we're passing it our main UI. Which we'll come to in a minute, which is what the app UI part here is for. And then we're just defining the different parts. So we're telling it we want all of this in a grid container, which is this is Microsoft Fluent UI. We have the header part, which we already defined up top, the side navigation, the main part, and the footer. So all of these things are passed to this function. And the CSS that I showed you in the beginning, the cascading style sheet that I showed you in the beginning, is what controls where these things go within the app. So we're not going to go into that in any detail today. But here we basically close that function. So we have a layout function here that we can call later. Then there's a couple of additional things. There's some, when we have generally with Shiny apps, we need to add some dependencies and resources. So I'm going to put that in here. So this is basically stuff that the app needs for whether it's style sheets or things like this. So and we're using Shiny Router, the package. So that's one resource path for that. and the JavaScript that comes with that. So we shouldn't, there's not much here to really define, and we can add other dependencies as well, including like if you have, for example, a more complex app and you have other folders in here where you are storing images, or you are storing like infographics or documents or whatever else you want to be part of the app, you can add these resource paths to the app as well, so that it's so that you have that mapped and you can call it easily from across the whole app. And one thing that's really important to remember here is that this app.r script is what controls everything within our Shiny app. So this is kind of the center part, the node that keeps it all together and manages everything. So that's really important. So now I'm going to just move into the two parts here, which are a bit more, you know, generally for those of you who've done any kind of Shiny development before, this would be quite familiar. And I'm going to start by just putting together the UI part here, or the user interface part. And I'll walk you through it quickly, but I'm just going to paste this part in, and then, because I wanted to spend a bit more time going on when we get to the modules themselves, so that we don't run out of time. I'm basically pasting in here. But again, I hope most of you have been able to download from GitHub, and so that you know, you can look through the code there. Basically, here I have the what goes into the UI part of the app. So just forget about this stuff. We don't need that here because we're not using Golden today. But this is, we wrap it inside a tag list function, which is basically Shiny tags, or to do with HTML. And then we have scripts here, and this is just sort of standard stuff that we can lift out of the Shiny Fluent library. So this is referring to the JavaScript modules and the React part. You don't need to really worry about this, just copy paste this in. And then we have the more interesting part, which is the actual Fluent page. So for those of you who have developed dashboards before, I'm sure you've used a lot of different libraries, and you know, if you use semantic UI, for example, then you would specify a semantic page, etc. So this is now Fluent page is the function from Fluent UI, from that library, Shiny Fluent. We're suppressing dependencies like Bootstrap. I generally just put that in, it's not necessary here, but and then we have some dependencies around the HTML tools. So then one of them is the Office UI Fabric Core, which is partly where we get the icons from, the version, and then the URL for that, and the Fabric CSS that comes with that. Again, this is pretty standard stuff. You can, that kind of, you would put into any app that you develop using this approach. Then we have the body part here. And this is the important thing to notice here, is that we have the class, of course, and then the direction, which is left to right, LTR. But then the layout here is the important thing to notice, is that where we specify router UI. So essentially, this is where we're going to be routing our UI, our modules. So if you go back up here, remember we did this layout function here, and the main UI part here, which is what the function takes as input, is what you pass to the main section of the app here. So main UI goes into the main section there, and we're telling it down here that main UI is router UI, right? So it's wrapped inside there, and that allows us to create that navigation, the routing to the different modules in our app. And then finally, we have some tags at the bottom here, just for the sort of custom style. If we have any custom styling, which we do, the style.css here, and anything else to do with JavaScript and the routing. So that's basically the app UI in our dashboard, and it's pretty short and nifty, not too much in here, because this is really like where we just set things up and control things. So this is not the content of our app. So now the next thing we need to do, of course, is to deal with our server logic. And we'll be working on that as we go. But there's one thing that is a bit particular or very particular to when we use Shiny router, is that we need to specify within the server part the router server, so that it knows, because here we're asking for the router UI, and then we need to pass it the router service. So we need this additional line, which is you would normally not have in a app server kind of part of the script. So that part is really important. Otherwise, the routing is not going to work. And then below here, we're going to call our modules. So we've got, as I said, we have two modules here, and call module is a bit old-fashioned, so there's better functions for this, but I've just kept it familiar for those of us who have done a little bit of work with modules. So basically, if you remember, up top we had the routing, and when we did the routing, we specified the UI part of our modules right here. So the map UI, the home UI. So what we're doing down here at the bottom, and the reason that UI part is not inside the app UI is that we've placed it inside this router. So I hope that makes sense. And this is the reason why we have that call for router $UI within our app UI here, this part right here, right? So down here, what we're doing is we're just telling our app where our modules are, and then they will be called. So the call module so this will call the home module, home server part. So as I mentioned in my introduction, all these every module in Shiny has its own UI and server logic. So this just tells it what server logic to call from the home module, and then from the map module. And then there's one final thing, and then at the bottom, of course, we have the Shiny app, the usual. But there's one final thing that we want to do at the top, because we're going to be creating two scripts here that will contain our modules. So I'm just going to call them map_home.r and mod_home.r and mod_map.r. So those are our two modules. We haven't made them yet. Yeah, go on.
I think there's a question that you have to ask now, because later maybe you'll be lost in it. So I'm just going to put that in the chat, because I think I can't read it. Yes. So maybe just check the question.
Yeah. About Fabric UI, it just depends on your version, I suppose. So the way I'm using Fabric Core here, but you can experiment with that. So the question is about whether one could use Office UI Fabric JS instead of Office UI Fabric Core. Yeah, so I would experiment with that. There's a lot of flexibility here, and yeah. So I would just say, try it out and see if it works, which is kind of my approach to a lot of things when it comes to programming. So, but yes, there's lots of flexibility, and I should also mention that Shiny Fluent, the library here, it doesn't really cater to all the options that are available in Fluent UI. So that's also good to remember. But basically, just so we have under an hour, so I'm just going to continue with the modules. So here I'm just sourcing the modules so that my app sort of script knows where they are. We're just going to put them in the root or our folder. So what we need to do now is actually create those modules. I'm going to create a new file here. And as you might guess, I'm going to call it mod_home.r. This is already in the repository that was shared. So I have now this one, my mod_home.r, and then I'm going to create mod_map.r. Okay, so we have two R scripts in the root folder for the two modules that we're going to create. We'll start with the home.r module. And basically, as I mentioned, these modules, they have their own UI and server logic. And we basically start by defining the name of the function. So mod home UI is the name of our function, and the ID part refers to it's just the idea of the part. But what's different now relative to a normal Shiny app is that we need to specify or kind of have each module needs its own namespace. So we use this function called ns, capital N, capital S, to automatically create a namespace for this module. And we'll come back to that in a minute. This is really important because your modules are not going to work unless you have the namespace set up properly, because otherwise it won't really know what you are. As you're passing things from your server logic, say for example a graph, and you want to render it or show it or output in the UI part, unless you specify a namespace that is specific to this module, it won't show up. So it basically won't work. Then we need to start with a tag list. So that's sort of a wrapper around here. And then again, like we saw in we will do create a Fluent page. We saw that in the app.r as well. So we're wrapping it inside a Fluent page. And then there's a couple of things that we're going to do here, but there's a function in Fluent, in Shiny Fluent called stack. You can find it, which basically allows us to set up a few things in terms. It's more like a utility function that allows us to set up, for example, the gaps between elements in our app, etc. So if I switch just quickly to show you some of the documentation, this is let's see. It's a bit hard to see when this thing is in the way. Okay, so if we go to the documentation for Shiny UI, or for Fluent UI at Microsoft, you'll see descriptions of all these different elements of the layouts, iconography, etc., etc. So there's a lot of really good documentation, and you can actually read it and pretty much it pretty much translates directly to the functions that you see in Shiny Fluent. So this is something I would recommend you go and look at. We have some of the basic inputs here and the commands, the menus, and the navs, and you already saw the nav function in the library that we used in the app.r. And then we have all these different utilities here. So that's the utility functions I talked about, and stack is one of them. If we click on it, it will basically show us different elements of that. So the different properties, so here's where we set the alignment, whether we want things to stretch, and how we want things to be organized on the page. So it makes life a lot easier in some respects. And so that's the reason for that function. And one of the things, we're going to keep it quite simple for now, but one of the things we're going to do is we're going to define tokens and as a list, and then and one of them is the gap between the children. So if we have, for example, cards and boxes and things in our app, then that's one thing we can set. So the tokens equals this children gap. Sorry, it should be equals 10. So that's just the gap. So 10 pixels. Again, you can pick this all up from the Git scripts. So you don't have to, if you can't follow 100% here, that's fine. So I'm just going to continue down a little bit, and then we're going to set our page up and going to create a div. And then for that div, we're going to have a class. So if we go back to the documentation, we can read about these different classes, but for the sake of time, we're going to use a so-called MS Grid or Microsoft Grid class, and the direction equals LTR, left to right. And this is similar to what you saw in the app.r script as well. And then from here, now we have the grid element. So that basically sets the page up in terms of the grid. And then we can, if we go and look at this grid system that is Fluent UI here on the documentation page, we see that we have a grid system with 12 columns. And so we can define, if we define a size 1, for example, that would mean, so we can have 12 size 1s, or we can have 6 size 2s, or we can have 4 size 3s, so just do the math, or 2 size 6s, or you can have a size 8 and a size 4, or you can have a size 12, and a size 12 would span the whole page. Width in terms of the width. And there's more here on the documentation. You'll see this is quite similar to what you see in R, because we're basically just wrapping our code around this. But the idea is that you with Fluent UI, you can also cater to different screen sizes. So you can have a SM6, that means that you have a column size of 6 for a small screen, column size of 4 for a medium screen, column size 2 for a large screen, etc. So in other words, you can make your solution or your app behave differently on a mobile versus a desktop versus whatever. So if depending on what device your users are on, it can switch behavior. It can also hide certain things on certain types of devices. So if you want some elements to only show on a desktop and not show, for example, on a mobile or on an iPad or something, then that's also possible. But that's just very quickly, and I know this is moving very fast, but that's the grid system. And then we're going to have another div here where we are defining a row for our content. So I'm just going to set class equals ms grid row. Again, these things you will eventually learn, like the names of these things. So this is all part of sort of what comes with the package in terms of if you're using a different design, different framework like semantic, I mentioned earlier, semantic UI. If you were using that, then these classes are also different. So this is specific to Fluent UI and to Fluent Page, right? And then we have now basically a grid. We have a row where we're going to put some content. And I'm going to just copy paste a few things in here to start with, and just a bit of text at the top. Okay, so I'm putting essentially just a very simple line of text in here where I say, welcome to the unofficial Kenya Census dashboard, and H1 at the beginning there, for those of you who are new, means header 1. So it's basically a function to make it very convenient in HTML to convert this into a header 1, and H3 means header 3, right? So we have header 1, header 3, and a row, and then we're going to close out our row. So we see here that we have a row. We just have some simple text in that row. So div starting, opening here, closing here. And then we always have to remember these commas in our UIs. So don't forget the commas as you go down between elements. So here from row, comma, and then comma and no comma here as we close, and then comma again as we go to the next div. So I'm going to create another div called title. Here. This is just to show you an example. None of this is actually necessary, but this shows you how you can use different classes from within Fluent, Shiny Fluent, or Fluent UI rather, to display text in different ways. And so here I've just put some information on Kenya's population, just from something I found online in the Kenya statistics, and basically just summarizing a little bit around the trends over the last several years. And that's another div, so that's closing there, comma. We go again to another div and we create a new row. And this is where it sort of starts to to get a bit interesting. So we create another row, and then we're going to create 2 columns. Here. Okay, so basically, if you remember what I was showing you on that Fluent UI web page, you saw that there in the grid system you have different sizes, and you can specify different sizes for different devices. So what I'm doing here, don't worry about this part so much, but this is just for for small size, and medium size screens. But for large screens, which is what we have here on the computer, I'm specifying a size 6 there, which basically means that it's going to take up half of my viewport or my browser when we run the app. So this 6 here, and then we'll have another column with size 6 next to it. It goes left to right, so that's also good to remember. Then there's other things we can add to this, and to basically, for the UI part of it, and I'm going to just paste that in here now for the sake of time. And this is just basically creating some shading. I want to essentially create a card, which is what I'm specifying here. But I want that card to kind of have a bit of shade, so it sort of comes out a little bit on my page. And you can go read about that here again. There's a lot of documentation around that. And read what different levels of shade you can use, etc. The MS depth 8 is fairly subtle, but you can increase that as well if you want more depth. And then we're going to, within here, we're going to come back and put our graph in a minute. So we're going to use Plotly for the graph, and we'll come back and put that in here in a second. So for now, I'm going to just close up here. So you see, I need my parentheses to line up. So now I have that row. I don't want all the way to the row though. So I have my column, and then here you can see the closing parentheses up here. So this is my first column, and then comma. Then I can essentially just, to make it simple, I can basically copy that to the next section here, so then that gives me my next column, and then I basically just change the title. Okay. So what I'm basically doing here is creating 2 columns. One that will have a graphic showing total population in each county in Kenya. Another one that will have a graphic showing the population density in each county in Kenya. Okay, so we'll come back and sort of populate that. You see there's a comma here, and we need another line. So we'll have another line coming in here with our actual graphic. We'll come back to that in a second. So now what I want to do is just make sure, as we wrap up here, that everything is nice and clean in terms of the parentheses, right? So we need to make sure we're closing everything. So here, if I add one more parentheses here, we're basically closing that row. And then I need another one for my div, the grid, actually from here. So that's the grid. And then I need another one for my stack. And then another one for my Fluent page. And then finally for my tag list. Okay. So in VS Code that I use here, you can see that it automatically does this. It sort of indents, and so it's quite easy to follow. And there's some nice things you can install in terms of extensions to also make life easier for you, especially if you have slightly complex layouts. But so that's the UI part. The only part that's missing in the UI part now are the actual graphics. So we're going to go ahead and create those right now. And that happens in the server part of our home module, right? So again, let me just bring that up. I'm going to copy paste this in just the beginning of it. So this is where our server logic goes. And we're going to create this mod home server object and the function, and it's a function with an input, an output, and a session, the session information. And then, as I mentioned in the UI part, we have the session, the namespace for the session. And this is again very important because that's what allows us to connect what we're going to be doing in our server logic to what we have in our UI. And then I just put the curly bracket there to close off that so we don't forget that. I mean, generally with anything, obviously in coding, but especially with app development and a lot of divs and things like this, keeping track of your parentheses is can be a headache. So that's always something to really pay attention to as you go. Now I'm going to quickly walk you through some of the data sets that we'll be using, or not so much the data, but just load them here and just quickly introduce them to you. So we're basically going to create two tables. Yeah, and so population.gender.county. So the gender data by county for the Kenya population from the census library. And then I'm reading it here as a data table. And then this is just the data set from the library. So once you've loaded the library, R will know where that is. Then we have here the population area county. And then I'm just quickly here changing the column names just to make it a bit easier when I'm plotting later. So I'm just saying column names, and this is standard R, so nothing much to worry about. One of the reasons I'm introducing the data table to you here is that data table is extremely fast and performant. And so if you are working on Shiny apps, very often one of the key things, and we're not going to cover today some more complex things around reactive expressions and observe events and things like that. But in general, like if you have something that is taking a lot of time to process, your Shiny app is going to be laggy and your users are going to be frustrated. So there's a lot of quite recent developments that are interesting in terms of data formats, like Feather, Parquet, and so on, that have also made their way into R. So those are also worth exploring, but a really well kind of mature library is data table, and it really allows you, if you have large data sets, to essentially run mutations, filtering, etc. on those in a very fast way. So I'm doing one example here in this line that you see. I'm just taking the population by an area by county, and then I am just removing removing some empty strings. So there's in some of the county names, when I was preparing for this, I just noticed that some of the county names have some lagging spaces and stuff like that. So I'm just cleaning up a little, and the way we do that, so you could do that with dplyr here using mutate. But what I'm doing is I'm just saying for county, and then in data table, this syntax, the colon and the equals is the same, similar. It means that you're doing a mutation. And then I'm using the stringer library that we loaded in the app.r to use this function string remove all. So that removes all patterns of all these spaces from the county field. So very simple, but just an example of what you can do with data table. And we'll come back and show another example of how we can filter with data table. So what we're going to do now is we're going to create two graphics that we're going to then put into our UI part, right, to display in our app. So I'm going to use Plotly for this. And we first need to define an output. So output $, and then I'm going to call it population gender county. If you're a fan of shorter names for your outputs, feel free to do whatever you fancy. I tend to recommend that one uses names that are meaningful, so that future you, as people like to call yourself in a while, like that future you recognizes what you're looking at, but don't make them overly long or complex, so that you we'll have a hard time finding them. So then we're going to create a plotly graph. So we need this render plotly function. And then if you look carefully, you'll see there's a parentheses, and then there's a sort of a squiggly parentheses there inside of it. So this is sort of shiny notation here, not normal, just parentheses. So don't forget the squiggly, close it down here. Now we have the data set we're going to be using, Kenya, population by gender in each county. And yeah, there was another issue in the data set that I was noticing when I was doing this. So there's in the county, there's a county called total. So so I'm filtering that out. So I don't want this county included called total, right? So it's just saying load this data set, population, gender by county in Kenya, and filter out, don't include total. Faith, there's something drawing on my screen. I don't know if it's from your side or I don't think my annotation is there.
I don't know. Sorry for that.
Okay. No, that's fine. I mean, I can still type, so it's fine. So yeah, and then I'm going to just pipe this into Plotly. So that's the data set. We're feeding in the data on the gender by county. We're dropping any county called total. So do not include. That's what that exclamation mark equals means. And then we are calling the function plot_ly, which is plotly. You remember from the app.r that we loaded plotly, library plotly. Then we will specify what we want on the x-axis. And I'm going to reorder that. So because what I would like is for to have the order of the bars. I'm going to create a bar chart. So a very simple bar chart, but I want the order to go by the total population. So we're in decreasing order. So that's why I use this function reorder. Then I want the counties on my x-axis. And then I want them ordered by negative total. So the total population. Not by gender, but the total population in the ordering. And then on my y-axis here, I'm going to put the male population. Okay, and note the squiggly line before reorder here for the x-axis and before male. So that's just telling Plotly to use the column male from this data set. And here it's telling it to use county, but to reorder the county in decreasing order with the population, total population. So that's just the notation there. And for those of you used to other, like some of the BASAR stuff and so on, you'll be very familiar with this. So it's a little bit different from if you use, for example, ggplot2, but it's actually, once you get into it, it's not that different. And then the type of graph I'm going to use is the bar chart. So I just do type equals bar. And then I'm just going to have a color for my bars, of course. So we'll just do blue. So you have to wrap that in that I. So it's sort of, I don't know what I actually stands for, but that's what you need to do. And then the name. So that's what will go in our legend is male. Okay. And then we have the name, male population, then we can close out that part. And we then pipe in, because I also want the female population in my graph. So what I'm going to use here, I'm going to use a function called add bars. So I'm going to add another set of bars. And then just for simplicity, I'm just going to copy something that I just already wrote here. So I have add bars, and then X on the X-axis, same as before, county reordered by total. And then on the Y-axis this time around, we have female. The type is bar, and the color is orange, or whatever other color you fancy. You can also, you can specify any color essentially in Plotly. And then we're gonna go pipe that into a bit of layout where we will just essentially just tweak the titles a little bit of the graph. Let's see. So move this. So you'll see here layout x-axis list title equals county. So that means I want the title on the x-axis to be county and the title on the y-axis to be population in 2019. Okay, so that's just the layout part, and there's a lot of pieces to Plotly. There's amazing stuff you can do, and you'll see in a minute why I'm using Plotly. It's basically for the interactivity. Now we have and if you look here, this is closed out here for the render Plotly. So we now have a graph of the population by county and gender. And now what we need to do for that to appear in our dashboard, we need to take that output and we need to put it inside our UI logic. So let's copy that output name, the name of that output, and go back up here. And then remember we created this section in our UI, and we have here we want here the population by gender and county. So then what we need to do in order to do that is we need to use a function called Plotly output. And what's different, and then, you know, in sort of vanilla Shiny, you would have something like this. Oops, sorry, the code there on the wrong side, but you would have a Plotly output, and then you would quote the output from your server logic. What's different here, if you remember, I mentioned earlier the namespace. What's different is that we need to wrap our output in this NS function that we created, so that it knows what it's looking for within the module, so that the module is basically isolated from the rest of your app. And that's why it has its own namespace. And then there's just a couple of small things I'll do here, just to set for the Plotly output, just to set the height and the width, right? So you can set that to whatever you want. If you want a smaller graph, you can do that here. Width also just means that whatever this is fixed in pixels, but then this just adapts to the width of the element that in the div that we're looking at. Okay. So that's the first graph, and now we have that in our first column. And then I'm just quickly, for the sake of time, gonna copy paste our next part in our server logic. So I said we're gonna create two graphs. Okay. And you see here now what I've done, basically same procedure. And then by creating now a population density by county graph. I'm dropping the county called Kenya because I don't want the total. And then I'm doing Plotly, x-axis population density, y-axis reorder. And the reason I'm doing this is that, so this is where Plotly is a little bit finicky in the beginning, is that I want this to be horizontal. So I'm actually just flipping around the y-axis and the x-axis in terms of the content. So because essentially it will, in the way it's represented on the screen, it will look like you have your population density going horizontal and your counties going vertical on the y-axis. And then they're reordered by population density. And I set a color, and I have the layout here with the title for the x-axis and the y-axis. So same procedure as before, but a different name for this output, right? So let's go back up to our UI here and put this into our app to display it. So Plotly output. remember the NS quotes, Hope Dense County is the name. And then we have the height equals 550 pixels, width equals, right? So now we have essentially created in our server logic 2 graphics, 2 plots. We've loaded some data, of course, first, done a little bit of fixing of the data or whatever, mutation, etc. And then we do a bit of filtering as we pass it into the graphic and or to the plot using plot B. And then we've placed these graphics inside our UI elements in 2 columns, which sit on top of basically will be rendered inside a card. And in the CSS that I showed in the very beginning, I've specified what I want the card to look like. So we'll see that in a minute. Okay. Normally, you would probably be doing this one module at a time, and then you'd be testing and moving along like that. But I'm going to go straight through and do the other module, and then we're going to see if this all works. But essentially now I have my first module, and the part of the module that I need in my app.r is basically, so here you have mod home server. If we go back to app.r at the bottom where we are calling the modules, we see here mod home server, and then the namespace, the home UI 1. Okay, so that's the first part, the first module. Now I'm going to move on to the next one, and I'm going to do the next one really quick. So because we're going to run out of time if we're going to have some questions. So I'll copy paste from what I prepared already in terms of the UI part, and then but again you can look at this on the GitHub repository. So it's same procedure, namespace for this module, tag list, fluent page, stack, same as before. Create a grid, create a row, put some text if you want. I use the same text I think as before. Title, same as before. I just want the 2 pages for the header part, for the top part of them to look the same. And then I add a row, a card, and what I'm doing here is just putting in a map of the population in each county. And then in the other column, I'm putting in the population density in each country as a map, a leaflet map. Okay, so we'll skip down to the server logic here, and let me just get that. Same procedure as before. So we've escaped out of the UI here with the squiggly line, and then we have our server logic. And then again, same as before, but the name now is mod_map_server, namespace. And then from the library that Chuck put together for the county data, the R Kenya census library, there is a shapefile. It's in normal sort of, if you load it, it's just a normal in SP kind of type object in R. So what I'm doing here is I'm just loading the shapefile from the library. Then I'm converting it to a simple features or SF type of vector or polygon. So Kenya counties, STSSF just means to take that old school spatial object from from that shapefile and convert it into an SF object. I keep the name the same because I'm just overwriting. And then what I do is I take that and then I pipe it through, do a ST transform, which means that I'm just reprojecting because the shape file is in UTM. But when we use leaflet, which I'll show in a second, we need to use either lat long or like preferably lat long, but we could use even some sort of Mercator kind of projection. But the idea is that 4326 here just represents geometric or lat long coordinates. So that's the code. So that's what I'm using that. And then I'm mutating here. So this is very familiar to those who are using dplyr. population, I'm just it was a factor, so I'm essentially just converting it into a numeric field because I'm going to be using it later. And then once I have the data in, when we have the data in this format, the Kenya counties here, then we will, it basically is it's basically then a SF object, which is more or less like a data frame, but with an extra column for the geometry, which is the polygons that we're going to be using. Then I need two things before we go to the mapping, and that is I need to put some color to things. So what I'm doing is I'm using a function called color quantile. There are other functions that you can use from Leaflet, like color numeric, color factor, etc. So you can explore those too. But I'm basically just going to take the data, the two variables, one population, the other one population density or PD. I'm going to use a yellow, orange, red color space from the library called R Color Brewer or Color Brewer, and which has a good spread. And then I'm going to bin this into basically 4 parts. So you will have the population, for example, in the first 20 up to the 25th quantile, 50th, 75th, and 100th. So essentially just kind of making discrete classes out of that. And same for the population density here. And then I can move into the leaflet part. So here I'm creating an output map counties. And then if you remember, we used in the last module, we used render plotly. Here we're using render leaflet. So that's because we're going to make a leaflet map. So render leaflet, same open, close with the squiggly and the normal parentheses. Kenya counties is our data set. We're feeding it into leaflet. We're adding some tiles, just straight leaflet out of the box stuff, nothing tweaking here. And then we add the polygons. So what I'm going to do here is add the polygons. Kenya counties is our polygon. So we don't have to specify that here because we've already piped in the data set. So I'm going to have no stroke, and I'm going to have the fill, and the fill color is going to be from the palette that I created here. So that's the function. And then population is the variable. And then I set some opacity, and I make a label and do a bit of formatting, add a scale bar, add a legend, right? And then I do the same for population density. So once we have this, then we can, we feed into our columns again. So coming back here at the top, leaflet output, map pop counties, and then the namespace, wrap that, don't forget that, and the same for population density. So the two outputs from down here in our server logic, PD counties, there, into our UI. Okay, so that means that we now have the app.r script here, where everything is taken care of in terms of organizing the app. We're sourcing the two modules, the mod home and the mod map, right? These two are sitting here. We have rooted things. We're telling it what UI elements to root where. And that key here is then what we come back to in our nav down here. So the home here goes key home, or URL home as well. And then the same for the map here. So essentially we have two modules. We have the app.r that's controlling it all. And if we're lucky, this will work now. So if I just call shiny run app, open close, from my command line, or you could write a script for it, then it should be loading, and hopefully there's always an error, right? Error in mod home, could not find mod home UI. Let's see. I hope if you guys have there's probably something I overlooked when I was doing this, so. Again, okay. So there we go. So if you look in the screen I've shared here now, I've loaded it, and so what we have now is a very simple app. With what you pulled from GitHub, you should be able to, if you open that in RStudio, for example, or on VS Code, whatever you prefer, you can just run shiny run app, open close in the root folder, and that will launch the app in your browser, or in the case of RStudio, within its own sort of viewer or browser. And so what we have here is now a dashboard with a home page and a map page, right? So that's what we have in the navigation, on the navigation side. And this is what we specified in here. So we have home and map. So you see that corresponds to these. Our map icon has gone missing, could be my internet. But on the home page, we have two columns, and at the top we have some text. So we have the total population by gender in each county, population density in each county. And if we hover over the graphic, we can see pop-ups on with numbers of the population densities here, and here with the total population. Nairobi City, female population, male population. So that's one of the nice things about Plotly, is that it gives you this kind of interactivity in the graphics, and you can also zoom into just elements of the graphics. If you want to just see some counties, if I just want to see Kisii, Machakos, Kilifi, I can zoom in and see more detail. We see that in Machakos, it's pretty much 50-50 on the gender. In Kilifi, we have somewhat more, a bit more female population, same in Kisii, etc. So it gives you this kind of interactivity, which is really nice. And the same over here, there's a lot of flexibility. You can zoom in, zoom out. And there's a lot of other things we can do here. We can customize these pop-ups as well, so you can make that more complex and more informative for your users. So I do recommend that you have a look at Plotly in more detail. You can also use from ggplot2, you can also convert your ggplot graphs to Plotly. So that's an option, of course, as well. And then in the map module, now we have two maps, again, sitting within these nice green cards. And the green cards come from the style CSS file that we created. So if you remember in the very beginning, I talked about this, but here's the card part, and you see the color I've set here for that. And that's what we now have on our app, right? So we have a card on the left with the total population by county, and a map on the right with our population density by county. And then the legend shows the quantiles, so it sort of just pulls things apart a little bit. But if we hover over it, I made some labels that show the actual population. So for example, Marsabit, 459,785, Wajir, 781,000. And then, of course, these are interactive, so we can zoom into this map and look at it in more detail. Kiambu, Nairobi, much higher population. Same if we go into the population densities. Kiambu, someone muted me.
Yes, I think someone did. Please, okay, we can hear you, sorry.
Okay, I don't know when I dropped out, but I was just saying, I'm happy to take questions. We only have about 10 minutes to go on this session, I think, Faith. So, but essentially, this just shows you like a very simple dashboard that can literally be developed in a very short amount of time. And so, so one of the reasons like why I wanted to introduce you to this Shiny Fluent is essentially that, just almost out of the box here without very much tweaking, you can get something that looks quite elegant and it's functional. So yeah, thank you. I'll take questions.
Well, thank you, Dr. Tor. So this is Christopher. Sorry, I joined late. I'm also co-hosting this session with Faith. So we have a couple of questions. So just going to read them to you, and yeah, then we can. Okay, so the first question is, so is modularizing Shiny app customization exercise of the apps? So and if so, do one need to learn CSS first, or where do they start?
Yeah, so basically to start this, you don't really need to learn CSS unless you want to tweak. There's if you go and look at Shiny Fluent in their Git repository, there's already some ready-made files that you can start from. There are also other frameworks that you could use. So and libraries. So one library that is quite commonly used, and we do use quite a bit in-house as well, is called Golem, G-O-L-E-M. So that's another one that you could use, which basically sets up an app for you and makes it into our library. So you can essentially distribute your Shiny apps as a library as well. And it creates the folder structure, has functions to create your modules, etc. So that's one that's handy to look at. You don't have to learn or know CSS to modularize an app. Absolutely not. But it's something that obviously helps to learn if you want to tweak things further or make it sort of stand out in some way.
Okay, so I can see you projecting the questions there. Okay, fine. So another person from the audience wants to know more about the IDE you are using. I mean, I used to RStudio, so it was quite elegant. So do you mind?
Yeah, so I'm using something called Visual Studio Code. Also from it's actually also developed by Microsoft, and I also use RStudio, but just for simplicity here, like in terms of clarity, this is very good, and it's a great environment also for R programming. There's some nice extensions that you can install for R that allows you to also connect to the RStudio API. So yeah, so that's Visual Studio Code is what I use. Another reason why I use it is actually also that some of my work is in Python and notebooks and Jupyter and things like this, and so all of that can be done within Visual Studio Code.
Great, thank you. So yeah, well, will you mind doing a training on functional programming or effective programming in the future if a meetup was to be organized by Nairobi R?
Yeah,
or...
Of course not. That would be great.
Okay, fantastic. Good to know. I would be very interested to be part of that training. Yeah. So. Okay. So well, so most complex dashboards require GS, React, CS, etc. I think this is similar to the question that I asked earlier. So for those whose first programming language to learn was R, how would you advise them to get started? I think similar.
Yeah, it's similar. I mean, I guess I would say there's some very good resources online where one can sort of get started reading and so on, and then there are some really good courses online. So I would look for courses and materials, resources that you can read. I mean, that's how I learned these things myself. So yeah, I think that's what I would do.
I think that answers the next question. You'll of course kindly point us to the direction of getting the links to start with. Okay, so so there's this other question. If we put select input objects in module UI, I think this is the Shiny inputs on the UI.R. So how can we access the selected values and use them for data wrangling processes? Do we need to define module server?
Well, it depends. So if you're, it's more or less the same as you would in a normal, like a normal Shiny app without the modules. So the only thing you have to remember really is that you do have to, of course, if you're doing something with the data, that would happen in the server part in terms of wrangling it. And then your select input could come from your UI part. So the only thing you do have to remember is that you wrap it inside the namespace, the NS function there that I showed, so that it knows, what to look for essentially, or to find it. So yeah, more other than that, it's pretty much the same as it would be in a sort of regular shiny app.
Great. This is an interesting question here. So could we have an arrow on the map where origin and destination using the longitude and latitude on leaflet? So someone is looking at the traffic flow on certain roads. So where do they start if they want to do such a feature?
Oh, I would just start by, yeah, you can definitely do that. There's a lot of resources online on leaflet, so I would look at that. And if you want to, you could also go in and look at sort of the Java part of it, and so it's not, because not all of this is not specific to R, but there's a lot of resources, and some of those libraries that I put in the app.r script, which are leaflet extras and leafem and so on. So there's a number of others that add functionality to leaflet in R that have these types of things built in. So I would start there and use those types of extensions to leaflet.
Okay, so so the other question is if we create 2 or more reactive data in the module server, so how can we use those data in other modules, or just in the server part, or are they supposed to be used on the server part, or
yeah, so you can pass data between modules. You can also nest modules within other modules, and so essentially it's you don't have to have all the server logic of it be called from the app.r. You can also load it from another module. So you could then take the output from, say, for example, we had the one we did here with the home page. If you were doing some filtering on the data and you wanted to only pass a certain part of that data to a map, for example, you could design it so that you pass it as part of the function into that module. So in the server logic of the module sort of downstream that's using the data, you would then you would pass the data through to that module. So yeah, so it's possible to do, and it can be, there's a lot of different design patterns in terms of how you can achieve that, but yes, it's a lot of flexibility. Yeah.
Okay, I think the next question is pretty much similar towards the same direction. So basically each module has its own UI and server, which is then mapped into the main UIs and servers. Will you confirm that?
Yeah, basically. So I mean, what is the main, in terms of the main section, or the in this case the app.r part, the script there is basically just you just need to tell it what to load from where, and so that's why we're sourcing the files, and then and there's other ways of doing that as well. So I mentioned the Golem library for R, which you could have a look at. It's quite interesting, and which has a different approach, and which doesn't work out of the box with the kind of routing that we did today. So it requires a bit of tweaking if you're going to do routing. But if you're doing just a standard app with modules, that's worth a look, and then that will also give you some idea. And there's good documentation. So,
well, the last one is not really a question, but I think an appreciation. The fact that you showed that a very powerful mean package for plotting, that is Plotly. I personally use ggplot, then wrap it inside ggplotly, and I think what you just showed us here is that there's more power to that when you use Plotly directly. And thank you so much. Thank you so much. Yeah. Okay. No, okay, yeah. So once again, thank you so much, Dr. Tor, for the wonderful training, and the participants for actually joining. So I think we've eaten into much of our lunch break. It was supposed to be 20 minutes. We're having another session next, that is making Shiny up by Bryson. So you could join us. You can bring your lunch to the next session. But so much thanks to Dr. Tor for the wonderful session. We really learned a lot.
Thank you so much, Chris. Thanks everyone. Okay.
Bye. Thank you. Join us in the next session for making fast Shiny apps.